Hey guys, James with Esprit Tech, and welcome to this week's Esprit Tech live stream, episode 3. Today we're going to talk about the Central Box lineup from Jeti. Central Box is a power and signal distribution unit available in multiple sizes for multiple applications. And so I want to get in and kind of explain what each one's for, what the differences are. We've got a lot of questions on the new 210, 220, which one should I buy? So we want to get into some of that. And then we're going to dive in and show you a little bit of the programming on the inside of the unit so you can see that as well. The first one that we're going to go to is going to be the CB100. Now, if you're running a small aerobatic airplane and you still want dual receiver redundancy and overcurrent protection, then the CB100 is going to be for you. It's probably the unit that's going to be applicable in, say, your 30 to 50 cc aerobatic airplane, your typical aerobatic flyer, your bigger trainer, things that are limited on the servo numbers, but you still want those protections and that telemetry data. So I'm going to go ahead and show you the 100, basic idea for how to set it up, show you the front and back side of that in the transmitter as well. If we can bring up the overhead camera, I'm going to go ahead and go to 2. Now, this unit here, this is our CB100. It's a very small device. It's got 8 pin outs, 2 receiver in. It does have an external power connector, and it does have the overcurrent protection. So it does have the fused outputs. So keep in mind, if you're running this in anything bigger than the 30 cc airplane and you're running servos of over about 400 ounces of torque, this may not be the application for you. You may want to consider either going straight to a receiver that's not fused or going to a 200 without the fuses, and we'll get onto those later. So the 210, or the Central Box 100 does take 2 receiver inputs. In this application, we're running it on a DS12. So we're running right now with 2 2.4 receivers. In this situation, I'm using 2 of the R6 indoors just for space. The R6 indoors, actually any of our receivers with an EXT port can be used as primary and secondary receivers in a Central Box environment, as well as being able to use the 900 and the upcoming 900 NG. I didn't have a 900 on hand for this live stream, so we went ahead and just went 2.4 on all of our examples. What we've done is we set the DS12 up in double path and then set you up with 2 2.4s on the 100. In the transmitter side, I'm going to go ahead and jump back over. There we go. In the transmitter side, I am bound up to this 100, and so I'm going to go ahead and power that up real quick. Let that come up. We'll jump into our device explorer, and just like you guys that are used to running the 200, you'll see that the Central Box 100 does appear in your device explorer. You can click on that 100, log in directly. You do have the ability to expand out from the 100 as well. It does have an EX bus output via the EXT port, which can also be used for your telemetry input. In this device, you do have active telemetry, so you can go ahead and take a look and see. Currently, it's showing that we're pulling 0.1 amps at 7.4 volts, and we've burned 814 milliamp hours since I started setting up for this live stream. So that's your basic setup. This works really well if you're using a DSM dual battery monitoring system or dual battery switch. That will give you dual battery redundancy into the device, as well as the dual receiver redundancy and the telemetry and the fused outputs for overcurrent protection. So a really awesome setup in what you can see is a really small package. It's actually built on the same chassis as our 9 and 7 channel receivers, the R9, R7. So it doesn't take up a whole lot of space in the aircraft, and it gives you all of those benefits as well. So we're going to go ahead and move on to the next size in the Central Box setups. Now the next ones, everybody's familiar currently with the Central Box 200. The new product coming online are the 210 and the 220. Those are shipping now, so you guys that are getting those are taking advantage of all of the added benefits that we've brought into that particular device. Some subtle differences between the 210 and 220, and definitely quite a few differences differentiating it from the 200, the original 200. We'll cover those first. The reason we redesigned the unit was multifold. We had some situations with heat management in the device, so we went to an aluminum machine case with a heat bridge machined into the case, and I'm going to get this in the camera, and I don't know if you'll be able to pick that up. Yeah, there we go. Notice that in the machined aluminum case there is a protrusion in the case that actually contacts the heat sink on the board. Use a little thermal paste between the two. This draws the heat off of the processor into the case and out into the air much better than the plastic case did, so it helps keep the unit cooled down. The reason for that heat bridge is in the devices with polyfuses. Polyfuses are a thermal device, so any increase in temperature decreases how much current that fuse is going to hold. So think of the polyfuses as circuit breakers in your house. Very similar concept. If you have a 15 amp breaker, you're not going to plug in a 30 amp device. You're going to pop the breaker every time, and it's the same with these polyfuses that you have in the Central Box. Adding to the aluminum case, it went to a larger processor. The larger processor actually allows you to run Dytex telemetry servos on all of the outputs. Nice thing with that is originally you could only do that on the Rex receivers. We had a lot of people asking for that in the other devices, so we've added that to the Central Box. Both the 210 and the 220 have that capability. Differences between the 210 and 220, primarily you're looking at the polyfuses and the ability to give telemetry for those fuses. So the 210 was designed because we had pilots that were tripping the fuses on a very regular basis in the Central Box 200. We knew even with the new thermal capability of the new case, we were still going to have that happen for the guys that were running those 700 to 1,000 ounce servos and pulling huge amounts of power. The polyfuse is not designed for that kind of abuse. So for those guys, we actually designed the 210. It eliminated the polyfuses. This gives them the ability to just run wide open. It does remove the overcurrent protection that you get with the other units, but these guys were less concerned with the overcurrent and more concerned with not tripping a fuse and losing a surface. If you lose a surface like an elevator, it can be catastrophic. We only saw that in very large or very extreme 3D airplanes, and by those pilots who could really use those airplanes to their maximum limits. Those guys were having the problems with tripping the fuses. So we don't see that very often in the scale market. We don't see it very often in the jets, but for guys that are worried about it, you do have the ability to run the 210 and not run polyfuses. I want to go ahead and power up the 220 so that you guys can see what we're talking about as far as the telemetry. So I am going to first switch models. Let me jump into the 220. We'll add the power, and we'll pull our bind plug, which is acting as our switch. All right, now that the unit is up, I'll go ahead and switch cameras. Let me go back to one. And I want to jump in to Device Explorer again. Same thing here. Two 2.4 receivers and the Central Box. You'll see that we are using, in this particular instance, our 5i receivers instead of the R6i's we were using in the 100. Again, any receiver with an EXT can be used as your primary secondary receiver. Nice thing with a 220 for you guys that are flying DS24 is you guys have the ability to run both two 2.4 receivers and the 900 megahertz backup receiver. That would include an assist receiver as your primary, or a standard receiver as your primary, along with a 2.4 secondary and an R9 900 megahertz tertiary receiver. So that would give you a huge amount of redundancy. For you guys that are flying the 12, once the new 900 NG comes online, becomes available to you, you'll be able to run a single 2.4 and a single 900 into the Central Box 100, any of the 2s or the 400. So I want to show you in the Central Box 220 a couple of the things they've added. One of the things is if you go into the telemetry for the 220 in Device Explorer, it actually gives you the fuse status for every one of the 15 outputs. If you were to lose that output, you would go from a check mark to an X in this menu, as well as at the top of the telemetry menu, it tells you how many shorted outputs. So a number would appear there. We're not going to trip up the fuse or pop a poly fuse for this video. If you do want to see that, there are a few videos out there. One of our customers did some testing with both a 210 and 220 out of Europe and was able to show what happens when those fuses fail. The other change to the system is to allow Dytex servo operation. Currently we're running a Dytex micro servo in the throttle channel on this example. I'm going to jump over to that real quickly. So we've added the Dytex to channel 1, which is our throttle output, and you're able to see that the Dytex servo works as a standard servo. When the output is set to servo, in the transmitter you have the ability in alternative pin configuration to change that over to a Dytex servo. Now I've already set this servo up for telemetry, so now that we've done that, we still have full operation on the servo, but now we can actually jump into our telemetry settings for our servo telemetry and pull any of the telemetry values off of that and add those to our displayed telemetry. You have the ability to do that for all 15 of your servo outputs now through the Central Box 210 and 220. This is a huge add for us, for the guys that are wanting to fly the bigger Dytex servos in their scale applications, so they have the ability to tune the servo and program the servo through the computer. It is a Hall effect sensor, just like we talked about in the Dytex video, so there's a lot of benefits to that. This makes a really nice combination if you're building a big scale airplane. That's about the changes for the 220. Oh, I do want to mention as well, in the assist video in episode 1, those of you that watched that and were with me on that, I talked about how I would not recommend running assist with the 200. That has changed for me. My opinion has completely changed. I've done some testing with the new firmware. All of the switching works well. Don't forget that you are going to turn stabilization on EX bus on, and you're going to turn stabilize failsafe off. Those two things make a world of difference. It's going to make it run smoothly. When you switch to backup, you will not have stabilization, but you will have full connectivity and control of the aircraft, which is what we were having a problem with originally, is we were unable to switch from the primary to the secondary because of the assist. So again, I do recommend using that now with the 200. If you have any issues setting that up, like always, reach out to us and we can get you through it. But my testing satisfied me. I'm very happy with what we have. So I'm going to go ahead and power down the 220 and show you the last device. Okay, how do I clear? I'm sorry, I did get a question on how do you clear or reset telemetry on the CBs, e.g. if a shorted output in flight 1 but resolved in subsequent flights. Two questions actually in one there. I want to go ahead and talk about two things. I appreciate the question because that leads me to something else. Let's go ahead and power that back up and come back in. First of all, if a fuse fails, polyfuse is a self-healing device. It does require some time to heal. So if you pop one of the fuses, it's always a good idea to go ahead and put that plane aside. Let that plane rest for a good amount of time. And I don't mean, you know, fly another plane for one flight. It should be a situation where you do not fly that again for that day. I just want to clear that up. They can take as much as 24 hours. If it's a complete separation in the fuse, you want to leave that fuse, let it heal completely. It's going to be 100% when it comes back. If you put the plane aside, try and fly it again the same day. If the condition that caused the shorted output is not corrected, it's going to cause that shorted output quicker than it did the first time. So always a good idea to let those heal overnight, fly it again the next day. Now moving on to how do we clear telemetry. So again, in the Device Explorer, I'm going to go back. In the Central Box 210, or 200 and 220 and 210, because all three are telemetry devices. Actually, this would apply to all of the Central Boxes. When you go into the telemetry min-max screen, you can actually enter a clear min-max switch. So you scroll down to clear min-max switch, press the button, pull the desired control, and now I've assigned a min-max clear switch so that I can go in and clear my totals. So I say yes, and now I've gone back to a nice clean slate. Everything has started to run again, pulling new values. I hope that answers that question. That works in Device Explorer in the telemetry min-max screen, just to make sure you understand where we're at with that one. So now we're going to go ahead and jump back out into my main screen, and we will power down the 220. Oh, one thing I want to talk about with that as well. You do have the ability to run that 220, 210, or 200 in conjunction with the smaller 100 unit. So if you're building a very large scale airplane, or you needed more than the 15 channels, rather than worrying about jumpers and trying to pull things from the receiver, with the 210, 220, 200, 100, 400, you never want to plug a servo or power drawing output into the receiver that's plugged into the RX1, RX2 ports. Those ports are very, very limited current output ports. So anything more than that receiver is likely to cause you to burn out RX1 and RX2. Because that's indicated in the manual and in multiple videos, that is not a warranty situation. If you overload RX1 or RX2, they will not cover that. So you want to make sure that you're not using RX1 or RX2, the power from RX1 or RX2, to power any devices like servos or switches, gear, or lighting systems that are going to draw any current. So, okay, so now we'll jump over. You have the ability to daisy chain a 200 to a 100 to another 100. You have, like I say, a scale airplane, and you need 21 outputs. And you're obviously not going to get there in a Central Box 220, 200, 210. The 400 may be more than you want to put in the aircraft. It's an expensive device. It's a large device. You want to keep the package small. You have the ability to run externally a 100 daisy chain to your 210 or 220 and plug those other servo outputs into that device. On the next device I'm going to show you, we'll give you an example of how we've done that, but I do want to mention that it's possible to daisy chain the 100s both to another 100, any one of the 2s, or the 400. So now we can go ahead and shut down our 220, and we're going to change models in our transmitter so that we can bring up our 400. So let me power that up, make sure we chose the right model. We did. Polarity is always important. All right, perfect. So I'm going to jump over to 3. Okay, in this setup we're using the typical 2 R3 RSW receivers and the Central Box 400, as well as having a daisy chained Central Box 100 in the loop. As you can see, as we jump into our Device Explorer, let me jump back over to 1. All of your receivers, as well as There we go. All the receivers as well as both central boxes do appear. You have the ability to log into each of the central boxes from the transmitter to make changes. In the Central Box 400, you have control over all 4 of the EXT ports. EXT1 is primarily where you're going to plug in your third receiver if you're flying the 24. If you're flying a 12 and you're running a 400, it's a little overkill usually in models you're going to fly on the DS12. But if you are flying a DS12 and a 400 together, you could actually use EXT1 for telemetry. If you're flying a 24, you're probably going to use that for your 900 megahertz receiver. So it's nice to be able to adjust those. You also have your voltage settings. So you have the output voltage, or the BEC voltage, for your BEC output here. So you have the ability to adjust what that output voltage is. The reason for building in that BEC in the 400 is, of course, you can use that to power an ignition system. You can use that to power external 100s like we've done in this example. Here in this example, we are drawing our power from the external BEC in the 400, and we're running our signal to our EXT2, which is set up for EX bus. So we are communicating via EX bus out to the 100, which is acting again as power and signal distribution, while the secondary BEC in the 400 gives power to that 100. So if we go back a page, you have all of the standard setting configuration menus that you would find in your 210, 220. So if you've done a 200, thinking about moving up to a 400, there's nothing complicated in using that device. You have the same alternative pin configuration menu, your fail-safe menu, and servo output mapping, just like you have in the 100, which we can log directly into the 100 in our Device Explorer, and we have the same settings there. You'll notice that in the CB100, in the general settings, you have the ability to adjust your EXT port, as there's a single EXT port on the Central Box 100, either for adding another external device in EX bus, or set for Jeti Box for your telemetry input, EX bus for those telemetry devices that are EX capable. So I'll jump back out of that. So let's see. Okay, so Pablo, that's a really good question. How will it work with the assist if one RF fails? Depending on what you're flying, what system you're flying. If you're flying a 12 and you're backing up, let's say, the 2.4 assist with a... Jason, we can go ahead and go back to the main camera. If you're flying the assist and you're backing it up directly with a 900 megahertz receiver, through that assist receiver, it's very simple. Signal passes through the assist because that's your failed receiver. It's modified by the assist gyro system and passed on to the servos because it is acting as your signal and power distribution. If you're running it into a central box, what happens is the 2.4 primary receiver, your assist receiver, operates as normal. You lose the RF link to that assist receiver. The assist receiver, so long as you have set the intelligent failsafe off, you want to disable failsafe or disable stabilization in failsafe. So long as you've done that, no signal will come from the assist receiver. The central box will then make the determination to switch over to your secondary receiver. It's going to be the same whether you're flying 900 with an assist, or the DS12 with assist and a 900, or you're flying a 2.4 or 24 channel transmitter, the DS24, and you're running two 2.4s and a 900. It's going to do the same. When the assist fails, it will stop sending signal. The central box will switch to the secondary. If there's no 2.4 available to the secondary, then it will switch to that 900 receiver and run on 900. So long as the settings are correct and you test the settings on the ground to verify, you'll find that that works extremely well. The switchover is just like it is switching from 2.4 to 2.4 without assist. so long as you have the settings correct. That's going to be the key for that. So Pablo, I hope that answered that question. Pablo, you spoke to me as a side note about another thing, and everybody out there, keep your eyes open on our Facebook page as well. We're going to be throwing a video up there, real quick phone video we did on how to make some cool mixing. Those you guys flying scale using gear that are either tight fitting or gear with gear doors, it's going to be very applicable to you guys. It's not going to make it up onto the live stream or to YouTube, so definitely keep an eye out on the Facebook next week for that. That's going to answer the question, Pablo, that you had, and something a lot of guys have fought with. So that's a side note, but make sure you keep an eye on that Facebook page. Guys, don't forget as well, if you're watching this, you like the content, get involved. Send us suggestions. What do you want to see on the live stream? It's very important to us that, again, this benefits you guys. It takes a lot of time to set this up. I know it doesn't look like a whole lot, but it does take a lot of time to set up, and we want it to have a benefit. We want you guys to be getting something from this. So if there's stuff you want to see, make sure you reach out for it. Also, don't forget, if you do want to stay involved and you do want to know when we're running something new, hit that subscribe button. Give me a like. I want to see if I can get at least a couple up there. You guys have been really good so far. But hit that like button. Smash that subscribe button. Stay involved with us on this stream. If you guys have any questions or anything else that you guys want to see in the future going forward, make sure you reach out to me. You can call us here at the shop or send me an email directly at james@esprittech.com or hit us up at support@esprittech.com. Guys, it's been an awesome time with you. I can't wait to see you next week.